Good morning, or at least this morning for me. We're getting ready to start the next unit, which is about chemistry. And we're actually going to divide chemistry into 5 parts. And the first part is going to have one test, one unit, and it's going to be 4 different videos. So sections 3.1, 3.2, 3.3, and 3.4. This is about basic chemistry. So let's get started. There are your learning targets. Take time to write them down, please. It all starts off with the atom. The atom is the basic unit of matter in the universe. Every element on the periodic table, every piece of matter in the universe, it is composed of atoms. They're mostly too small to be seen by scientists, so scientists use models to help us develop ideas and properties about the atom. We now have microscopes that can see atoms, but they're not widely available. The atom consists of parts. Even though the atom is very tiny itself, it still consists of parts. And those parts are usually called particles, and because they're smaller than the atom itself, they're called subatomic particles. They are the protons, the neutrons, and the electrons. There's 2 major parts of the atom. The nucleus, which is where most of the mass is, and that's the center, and that's made up of the protons and the neutrons. Protons are positively charged. Sometimes they're abbreviated with a P with a positive sign. As I said, they make up the nucleus along with the neutrons. That should say neutrons, sorry. The number of protons is equal to the atomic number. So here's an example, one square out of the periodic table, and it shows the symbol of the element, the name of the element, its atomic number, and its atomic mass. So its atomic number is its order on the periodic table, number 1, number 2, number 3, number 4, but it's also the number of protons that an element has. So the number of protons and the atomic number is the same number. Neutrons, also found in the nucleus. Neutrons are called neutrons because they're neutral. They don't have a positive or negative charge, and they're sometimes written as a little n with a superscript 0, which means no charge. They make up part of the nucleus, and together with protons, they make up the atomic mass of that element. So if you look down here, you see the atomic mass, or sometimes called mass number. It's got 4, so that means in this case there's 2 protons, and the rest of them are neutrons, which means 2 neutrons. So helium has 2 protons, 2 neutrons, which is an atomic mass of 4. Now you can also use this information to find out the number of neutrons by simply taking the atomic mass, 4, and subtracting the protons, 2. That's how we get 2 neutrons. They're not always equal. Protons and neutrons are not always equal. Electrons. Electrons find themselves outside the nucleus, actually really far away from the nucleus. This picture doesn't do it justice. And electrons are very light. I mean, they have almost no mass, and they're found orbiting the nucleus at nearly the speed of light. There are 7 electron energy levels that the electrons can orbit in, but we're going to use the first 3. The first level of electrons closest to the nucleus can hold 2 electrons. The second level can hold up to 8, and the third level can hold up to 18. Now those numbers are really important, and we'll use those in class. In every atom, the number of protons equals the number of electrons. So for example, in this carbon atom, there are 6 protons. There are also 6 electrons. Since protons are positive and electrons are negative, the 6 and 6 balance out, and atoms are electrically neutral. All atoms on the periodic table are electrically neutral. Okay, so that's it for this first video. It's going to be very short. This one's only 4.5 minutes. Not a lot of notes to take down.